This is some highly theoretical stuff on my part, but I just wanted to try and make things based on good physical philosophy. Now, this is the Hertzsprung-Russell diagram. Now, you can ignore these top objects. What we're looking at here are the white dwarfs and the main sequence, supposedly stars, okay? Now, in basic physical philosophy, if you have an object that's really, really big, let's just put this at around 110 times the diameter of Earth, okay? That's about the diameter of the sun. How do you get something that big? Don't you think maybe it started off as something really, really small? Sure, you can do that. Or you can have it as starting off something as really, 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 really big, and then collapsing over time. You could probably do that too. In other words, you could have these as being new stars, and you can have white dwarfs as being new stars. So you have a new star being born really small, hot, and dense, and moving up this graph, and of course moving all the way up here, and then expanding out to its furthest reaches, and then falling back down this graph, and going all the way down to where it no longer shines. Of course, this is where the exoplanets are, and planets. And the genuine black dwarfs, not the theoretical, unobserved black dwarfs of establishment physics. Remember, in science, you have to be able to observe something, either directly or indirectly. The theoretical black dwarf of establishment has not been observed directly or indirectly. It has no grounds, it has no foundation inside of anything, which means the theoretical black dwarf of establishment is pseudoscience. Now, my listeners know that black dwarfs are comprised of rocks and minerals. That's the end stages of a star's evolutionary path. But I just wanted to throw this out there because it's been on my mind for quite some time, and I want to make sure that I give people as many options as possible. So yeah, you could start out with something really big and cools and collapses and dies. Or you could have something really small, born very violently and expanding out and dissipating its heat and energy away as light and solar flares, solar wind, and that kind of stuff. But here's some other notes I wanted to share with you. The reason why I don't have white dwarfs as being the beginning stages of stellar evolution is because they're so massive. Or the ending stage of stellar evolution is because they're so massive. I made a principle of stellar evolution / planet formation that if you have a star evolving, it loses mass and loses energy. Okay? Those are the two main things that a star does when it evolves. But white dwarfs, WDs, are really hot, really, really hot, about 15,000 Kelvin plus, and they're very massive. They're about as massive as the sun, only compressed into a tiny little ball. Now, does that look like to you the end stages of a star's evolution? No. It's violent. It radiates very strongly in the ultraviolet, which means it's a cancer factory. When we start exploring the stars, we need to make sure we avoid white dwarfs at all costs. WDs, whiskey deltas, because they're going to be powerful cancer factories. Let's just go ahead and just forget about these things when we go explore the stars. They're very dense, and I built this. They're fitting for the beginning stages of stellar evolution because they're so hot. If a star is born and it cools down to something like a planet, you're gonna have things really hot in the beginning. How is the star radiating all of its energy over many billions of years, losing mass and heat and light, become something even hotter? This is strange. That's like going out camping, okay, and you have a little campfire, you have your twig set up, okay, and you have the flames licking. This is a really crappy fire drawing. And your flames licking over the campfire. You know, you have your brick set up to shield the fire around all sides. And instead of, you know, the fire dying out and cooling and collapsing and becoming ashes, what Establishment has it doing, regardless of if the fuel is being burned and used up, is that they have it going bigger. The fire becomes bigger and hotter. Only then they also do a strange thing. They compress it. They compress it to something that's smaller than the original fire, but burns hotter and brighter than when it first started, regardless if there's no additional fuel being added to it. So their problems are very very obvious to somebody who just breaks them down into simple, easy to understand terms. And I have here, stars start really small and dense and expand, lose mass and cool and collapse into what are called planets. I just wanted to make sure I give people another option. Maybe they start out really big, like a red giant, and then they cool and collapse and lose heat and radiation to interstellar space. But this is much more theoretical than I think I like, because I think there's something about red giants that still is very confusing to me. And it's like, how is something that big? I don't know. Because the sun is really big, okay? The Earth is really big, but you know, to think that there are objects that are that coherent, I don't know. I think there's a missing piece of the puzzle. Missing piece. I think they're a missing piece. But basically, that's that in a nutshell. Just make sure when you look at things like this, you try to fit things together inside of patterns. And notice the things that they forget. For instance, you have, you know, your 3000 degree Kelvin. Now, Kelvin is very useful. I'd rather my listeners start thinking in terms of Kelvin, because it's an absolute scale. When you have 0 Kelvin, all motion stops. All with 3 L's. Hello. All motion stops. Molecular motion, in other words. Molecular, and, you know, the atom just completely freezes over. But this is very strange stuff. I'm sure we're going to do a lot more advanced stuff with temperatures near 0 Kelvin in the future. But anyways, pay attention to this, 30,000 Kelvin all the way down. And keep in mind, you know, they don't have, you know, the old stars on here, because the old stars don't shine, obviously. And then they give them a weird name called planets and exoplanets. But anyways, this is for you, Baz, if you want to look it over and give you some more ideas. I just want to make sure, my number one thing here is to make sure that people have new ideas, new ways of looking at things, new, I don't know, connections, you know, playing, you know, the game of connect the dots. You have 3 dots over here, 4 dots over there, 5 dots over here. And depending on how, you know, you connect the dots will determine, you know, what it is that you see. And, you know, sometimes maybe you'll see something like that. Or maybe if you did the same exact pattern over here somewhere, you know, you can connect the dots into a big circle or something like that. But basically, Establishment, they played connect the dots, and then they screwed it all up, and it's all over the place. But they were supposed to make a big circle out of it. But, you know, to each his own. Today is March 1st, 2016.